Hello, 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 hello. Good morning, Internet. Good afternoon. 12:01 p.m. Good morning, good afternoon, Internet. Welcome to another NL Mathman Stream Supreme. Here we go. Boot up my headset. Those guys on. Happy Friday, everybody. Hope the first week of distance teaching has found you well. We are of course all in it together, right? Um, it's good to be here helping you all out with what I can, right? Let me move over here. We're not getting my amazing. Let me just okay. Now seeing that I had actually I'm opening a Cliff Bar. This is my lunch today. This is today's lunch. There it is. No pea soup today. We've got oatmeal raisin walnut Cliff Bar. Approximately. Let me see here. 250 calories, 6 grams of fat. Yeah, what are you gonna do, right? So, um, yeah, we got a picture of pictures of Dougie's little Smokey here. Look at little Smokey. Here he is. Oh, you're not seeing that. There he goes. There's little buddy. There he is. Yep, he's a good boy. That is a picture from I think last summer out at the cabin. That's good. So, yeah, without further ado, I am going to get into the questions that we are doing today. So, going to need to, oh, hold on a second. Okay, so let me switch back over to the working display. Here we go. This is how it would normally look. And we still got Smokey hanging out up there in the corner. You can see him out being a good boy, just lying down in the shade here. Little fuzzy guy, little fuzzy boy. Okay. He's not here with me right now, though. It's not that he's not with us, like, in a negative sense. He's my parents' place in Gander, which is out, the exact middle of nowhere. I mean, I know people say that the place they're from is the middle of nowhere, right? But like Gander literally calls itself the crossroads of the world. I mean, you know, to be as generous as possible, it's maybe the crossroads of like central Newfoundland, but like it's the crossroads of what, right? It's the crossroads of like the TCH one way, and then like Gander Bay the other way. That's your crossroad, really? You just go north into Gander Bay. Oof, I don't know, boys. It's pretty haggard. It's not much of a claim to fame, no, is it? You turns down here to get to Gander Bay, my son. Yes, boy. That's you know, hey, sunny boys. But they got the chicken shack in Gander, right? That's important. That's the icon of the area, right? We even get our stand-up bits about that one. Hey, boy, got that the boulevard. Hey, boy, airport boulevard, almost 4 lanes. If you keep your wheels up on the sidewalk, right? You know what I'm saying. So today we have got several different topics that I'm going to go over. Let's see, I've got Math 1101C, Math 3102, Unit 1, Math 3101A, full course review, just a brief one, and then Math 2018, I've got a few pages for that. Now, even if you're not doing those courses, it's still a good idea to hang out and watch the what I'm going to be blathering on about. I will cover a lot of stuff, and I try to cover it as generally as I possibly can, so that even if you're not working on these activities exactly, that there will still be some benefit to watching my stream, right? But anyway, let's see, making sure everything's coming through loud and clear. I've fiddled once more with the levels. I should be in a glorious 60 frames per second here now. Let's see. Look how smooth my movements are. Look at that. Look how smooth that is. All right, 60 FPS now. We've increased it. So let me check. Are we dropping frames? Oh, a little bit, not very much though. 0.2%. 0.2% is not bad. I'm okay with that. So the first thing I'm going to get to today is going to be Math 1101C assignment. Well, it's going to be some questions off assignment 1. But anyway, Math 1101C. Okay, this is Unit 1. So, I'm going to ask, let's see, questions 1 through 7. So, what is the slope of the line passing through negative 6, 5 and negative 10, 3? Right? Well, our slope for any line is equal to our rise divided by our run. Right? Rise over run. Yeah, if you're in the UK, you call this gradient instead of slope, but it's exactly the same thing. I mean, occasionally I'll pass out a sheet to my students that'll say gradient on it because it's something I got left over. But, and I got to go through that spiel to explain. But anyway, slope is rise over run. But how do we calculate rise over run from 2 points? Like, is there a formula we can use? And why, yes, there is. So y is, we can call it the change in w. The change in y over the change in x, right? Delta, this triangle, is a symbol that in math or physics or any sort of algebra means change in. But that's going to be y2 minus y1 divided by x2 minus x1, like so. Right? So the points that we have here are going to be point 1, point I. Point 1 is going to be negative 6, 5. Point 2 is negative 10, 3. Right? So these are the x and y coordinates of our 2 points. I'm just going to go ahead and label them so I see it really specifically here. We have got, let's see, this is x1, this is y1, this is x2, and this is y2 over here. So once we go through and do this little guy up here, again, I'm being very undisciplined by writing my algebra to the right. Generally, we write our algebra down, right? But here I'm going to just write it across. Y2 is going to be 3, subtract y1, which is 5, over x2 is negative 10, subtract x1, which is negative 6. And the reason I put that guy in a bracket, and I am going to go down the page now, just to show you what I'm rambling about. The reason I put that in a bracket is to make it very clear that this is minus a negative 6. So 3 minus 5 is negative 2. Negative 10 minus a negative 6 is actually going to be negative 4. Right? Because if you can think of a negative number kind of like owing someone money, right? So if you owe someone $10 and then you owe them $6 less, so you're owing them less, right? That's kind of what this means. And owing less is like having more money, sort of, right? Very sort of. But in math, it is. In fact, in math, it's the same thing. So negative 10 minus negative 6, it's going to be a negative 4. We've got negative 2 over negative 4, which is, of course, positive 1 over 2. So the slope of the line in question 1 here is going to be a half. Easy, right? And I'm not going to go down through all of these ones, slope passing. So number 2 I'm going to skip because number 2 is just the same as number 1, just with different numbers. So you're equipped to do that one now, no problem. Number 3, actually let me zoom in a bit. I don't need the blank there, do I? Let me zoom in a touch. Zoom in a touch more. There we go. That's good. Yeah, look at that. Okay, number 3 then. All right, number 3 is a bit of a twist. So number 3 says a line has an x-intercept 4 and a y-intercept minus 9. What is the slope of the line? Interesting. That's a good question. Okay, so what if we were to draw this out, like as a quick graph? What's that going to look like? And normally, if I was to do this stream, I would have graph paper, but this is not the kind of time when one can be going out and picking up a lot of supplies. So I'm just going to draw my own little quick substitution for graph paper, but do as I say, not as I do. So please indeed use graph paper yourself if you have it. Brittany, Yes, you can drop in chat there what you would like me to cover. I will get to that probably after I get through this 1101C stuff. All right? But we know that this is the x coordinate, and this is the y coordinate, or the x-axis, rather. Sorry. But the x-intercept is 4, so that means it crosses the x-axis at 4. So I'm just going to 1, 2, 3, 4. It's really, really approximate. But our point then is going to be here. So I'll do the point in a different color, and I'll do it as an X just so we can see it a bit better. Right? But what are the exact coordinates of this point going to be? That's a really important question here for us. So it's, of course, 4 to the right, and our points are always x comma y, right? So it's going to be 4 comma 0. So an x-intercept always has the y-coordinate of 0, right? And that's because it's on the x-axis, which is this horizontal line, which means the y value is going to be 0 because it's right here in the middle. It has a y-intercept of -9. So what's that going to look like? Well, roughly 1, 2, 3, 4, 5, 6, 7, 8, 9. Run out a bit of space here. Anyway, that line is going to be down here, right? This one's going to be a 0, comma, -9. Right? If we were to draw the line, it would be this. So one useful thing to do, now you needn't take all this time and be this thorough with answering these questions. There are plenty of ways to do it faster. I'm just showing you, ways to see sort of the links between it, right? Because it's really, really, really important in my mind to get the reasons for why. A very good teacher that I taught with in the UK by the name of Carleen, one of the best pieces of advice she gave me early on is that no matter if students want necessarily always to learn the reasons behind it, still teach them the reasons behind it because a lot of them are going to get it eventually, even if right off the start people are like, oh, I just want to know how to solve the question and move on as quickly as possible. Once you start teaching them the reasons why all these things work together, they will build a better understanding over time. And then you can approach questions, even if it's a question that you don't really understand how to do exactly, by knowing the basics that underlie what you're doing, you can sort of figure it out as you're going, right? So what I'm showing here is this, we've now graphed this line. So I could, if I did this on graph paper, I could get the slope of the line from that, right? So we could easily now see the slope of the line. Well, what's it between here and here? What's the rise over run? Over run between these 2 points? Well, obviously it's going up 9 because it's going up to 0 and it's going to the right 4. So the rise is going to be 9. The run is going to be 4. Right? So it's 9 over 4. And we already know that now, thanks to us drawing out this graph. Now that might have been a bit more excessive than what we needed to do. We could do it a touch faster by using our slope is equal to, we could just say y2 minus y1 over x2 minus x1. We could go back and do that kind of thing again, right? And we could say that the y of the second point is going to be 0 because we know it's the x-intercept. The y of the first point is going to be -9. The x of the second point is going to be 4, and the x of the first point was 0 because we know it was the intercept, which gets us to 9 over 4. Or also, I mean, you could just see from the question itself that the numbers that we are working with are 9 and 4. So there's plenty of ways to figure that kind of stuff out. But personally, I think the best way to approach any of these is to understand the basics, be able to draw out the situation like this, and then you'll be able to find the answer. Right? So even if they throw you a curveball, if you've been practicing the basics, you'll be able to get those no problem. What is the slope-intercept form of the equation of the graphed line? Oh, easy. Okay, slope-intercept form. Slope-intercept form is the good old y equals mx plus b. It's the basics, the absolute basics of how you write out a line. It's called slope-intercept form because this is the slope and this is the y-intercept. Right? So we just need to get those two from this graph. So let's zoom in an extra bit. Zoom on in. Here we go. So how can we see the y-intercept? Well, it's right there. It's right here. It's the point on the y-axis that the line crosses, right? So we know that b is going to equal positive 2. And then m is going to be the rise over run. Now I just look at it and count, right? Just take 2 points on here where the line crosses exactly, and I can see that it's going down 1, 2, 3, and right 1. And then it crosses a point exactly right here. Down 1, 2, 3, and right 1. Okay? So we know that the rise over run, we know that there's going to be a 1 over 3, right? Or sorry, oh, my mistake. Rise is 3, run is 1, 3 over 1. And it's also going down. And since it's going down, we know this is going to be a negative. And we don't have the right over 1, because every whole number is over 1. So our answer for the slope then is just going to be m equals negative 3. So what is the equation of the line in slope-intercept form? Well, it's going to be, let me zoom out here. It is going to be y equals negative 3x plus 2. All right, good stuff. Okay, I'm gonna leave question 5. I'm gonna leave question 5 and see if these students do that one. Okay, do that one on your test, on your, this is not a test anyway. Do that one on your activity. Slope point form of a linear function that has sloped this and passes through 11 over 4. Okay, let's see. Am I going to cover this one? Let me see something. Okay, tell you what. I am going to bounce down here now. We're going to look at no, 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 no. I'll do number 6. I'll do number 6. The slope point form. Sure. Sure. Let's do that. I just wanted to be, I'm a bit leery about doing too many examples on one like this. But something from the notes I'll do. I'll do every question out of the notes that you ask. But on one like this that you're submitting to me, I am trying to leave sort of some of them out, right? But anyway, question 6 then. What is your slope point form? What does slope point form look like? Well, slope point form looks like, you see down here, number 8? See this guy right here? All right, yeah, there we go. I am on. So this one here, this is a slope point form, right? And we see here, we know that these are going to be sort of reversed, right? So if we were to graph this out, we would see that it passes through the point 4, negative 3, right? If you're ever unsure about these ones, about how these lines will look once they're graphed, we do have ways to solve that one. And let me show you here now. Yeah, actually, this is really good. This is a good aside here. Yeah, yeah. Always looking for good asides, that's right. But I'm going to go back over to my good pal. Hold on a second. Here we are. Yeah, there we go. Good stuff. Good stuff. So this is my Desmos, right? And I'm going to use this to show you last video again. That's unfortunate, NL Shelley. Yeah, I'm not sure what we can do about that. I am not dropping frames or anything. That might be on your end, unfortunately. Yeah, I appear to have not dropped any frames since those early ones right at the start. Okay. So, right, I want to just now camera's a little out of focus, so that might be My document cam, maybe. Yeah. This document cam, unfortunately, does leave a lot to be desired. It's, like I said yesterday, this camera is about as focused as something that takes pictures of Bigfoot. Oh, my goodness, I should not be showing my emails on stream. Ah, what am I doing? Okay, so let me go back. Working display. Is that it is a touch out of focus. Yes, that is unfortunate. It's a bit out of focus over here, isn't it? Yeah, this guy. This is an old Microsoft LifeCam that I had lying around in a drawer. There's not a ton I can do about that one right now. Maybe I'm not going to order anything off of wish.com or anything like that. That was anyway, let's go back over to this guy. So I am going to graph the line from question 8 here now, just so we can see how this works, right? But the line from question 8, just to bring it up here, say down here, I'm going to write this kind of big so you guys can see it. The line from question 8 is y plus 3, right, equals -3 over 5 x minus 4. Now we can't graph that into Desmos like this, right? Because we had to have y equals over here. So what I'm going to do is I'm just going to move this 3 over. So I'm going to call this y equals -3 over 5 x minus 4 minus 3, right? Because that's moved over. So let's go ahead and graph that guy and see how that ends up looking. So that's, put it in brackets, -3 over 5. Oh, close my bracket here like that. That's going to be multiplied by, open a bracket, x minus 4, close that bracket, and then minus 3. Okay? And we see here, you can see on our handy dandy Grapharino, that it's going to go through the point +4, -3. Right? Here it is, +4, -3. And where do we see +4, -3 in this over here? Well, we don't. We don't see +4, -3 here. What we see here is -4 and +3, right? So in slope point form, which is this guy, in slope point form, which is that guy there, the slope is right here, right? We can see here in this line that I've drawn on Desmos. Back over, here we go, good, good. We can see here that the slope is indeed -3 over 5, as if we say took this point, right? And then we would go -3, so say rise of -3, 1, 2, 3, 1, 2, 3, 4, 5. Hey, look, there it is, works out, checks out. So that is the slope, and our point is actually the opposite of both these coordinates. It's important to remember that it's the opposite. So it's going to be, the y coordinate is going to be -3, so down here. The x coordinate is going to be +4, so over here. And there it is. Okay. Oh, actually, each of these blocks is half. Anyway, so yeah, counting 3 blocks in 5 works, but also counting 6 blocks in 10 is what I would actually have to do to get the actual numbers of points. Still works fine. So this one here is our slope point form. Let me go back over to my working display. Here we go. That's slope point form. Flip back on over. Yeah, it's definitely a bit blurrier off to the side there. Have to take a look at that and see what I can do for that for Monday. But you know, you can't. They say you can't outcook your ingredients. Well, you can't. You can't out video your camera. But it's always that one over on the side that is out of focus, isn't it? In it. All right, I'll see what I can do with that. See what I can do. So question 6, what is the slope point form of a linear function that has slope 1 over 5 and passes through 11 comma 4? Well, we know our generic form, right? is going to be y minus the y coordinate equals the slope multiplied by x minus the x coordinate. Right? So we have y, subtract the y coordinate. Now the point that we're given is 11 comma 4. So our y point is positive 4, so it's going to be y minus 4. Our m, our slope, is going to be 1 over 5, like that, right? And then we keep our x here, and we subtract our x coordinate. Our x coordinate is negative 11, so if you subtract the negative 11, that's going to be plus 11. So there you go. Math 1101C Unit 1. It's going to be y minus 4 equals 1 over 5, x plus 11. Okay, let's see. Next up I am going to scroll on down to question 18. Question 18 was the next one that was asked about here. So let me zoom out a touch. Coordinates of the vertices of a triangle are -2, 5, 6, 8, and 1, -3. Algebraically determine whether or not this triangle is a right triangle. Excellent. That's a good question. Okay, you don't need to really see what number the question is on stream now, do you? So I can zoom in a little more. Little more. There we go. Yeah, it's about as zoomed in as I can possibly get it with that amount of space that I have. Okay, so let's go on to another page. And write it nice and big. Actually, sorry in advance, I'm going to wiggle the camera around a bit more. There we go. So now I've got math 1101C, Unit 1, and this is going to be question 18. Oh, now I'm zoomed in too far. There we go. There we go. Okay, good. So on question 18 then, we've got a triangle with 3 vertices. Now, I'm going to, again, right, I'm just going to draw out my coordinate plane here as best I can, just on blank paper. In general, for a question like this, you should always, always, always be using grid paper, but I ain't got that right now. So, P is -2, 5. -2, 1, 2, 3, 4, 5. -2, 5 is going to be about here, so this is point P. Right? Q is going to be 6, 8. 1, 2, 3, 4, 5, 6. And that was 1, 2, 3, 4, 5, 6, 7, 8. So 6, 8 is going to be about over here. And then R is going to be 1, -3. 1, 2, 3. So R is going to be about right here. Now, remember, of course, that I have drawn this freehand, very freehand. So this is not necessarily, even if this looks like a right triangle, or doesn't look like a right triangle, that's no concrete proof one way or another, because all I've done is draw this out. Right? But what we have to know, it's important to know, is that this is 0.1, -3. That's essential. This is 0.68, and this is 0.2, 5. Now remember what I mentioned before about about my gel ink smudging? See, there it is. There it is, but it's worth the trade-off. They're nice pens. So what we need to find out to determine if it's a right triangle. So a right triangle, what do we know about a right triangle? Well, a right triangle always contains a right angle, right? Okay, so that's one thing we know. How does that help us? Well, one thing we know about right angles involve perpendicular lines. If lines are perpendicular, that means they meet at a right angle, right? So you see here, right? If something is a right angle, it looks kind of like this, right? And then this one here is 90 degrees, right? And these two lines, this line and this line, are perpendicular. And what do we know about perpendicular lines? Well, we know that perpendicular lines have the negative inverse of each, I'll say, of each other's slopes, right? So, for example, if example, the line has slope 2 over 3, a perpendicular line has slope what? What's it going to be? Negative 3 over 2, right? Negative inverse, or I could say the negative reciprocal. Yeah, negative reciprocal is the word that we use more properly. So this is the negative reciprocal. So what we have to find here is we have to find the slopes of all three of these lines, and then we find out if any pair is the negative reciprocal of another. Right? You could start off with this point, and right from the start, needn't draw with the triangle and write out all these notes, of course, but I'm doing it to be, to show the background behind why we're doing it. Hope you guys heard that slurps on mic there. It's good stuff. So let's see. I'm going to go line. So we're going to have three lines. It's going to be line PR. It's actually callback. It's a callback to one of the previous ones. It's a line segment, obviously. Line segment PR, not a line. Right? But still, we'll call it a line. I'll write it in. You can never be too pedantic. Right? Absolutely can never be too pedantic about this kind of stuff. So the line segment PR then. It is a little bit blurry on there this time, isn't it? Maybe yeah, I'll have to try different filtering. So anyway, line segment PR, the slope is of course going to be y2 minus y1 over x2 minus x1, right? So here, I'm going to take P to be the first one, and then R to be the second one. So we're going to have y2 is going to be this negative 3, this one here. Y1 is going to be 5, negative 3 minus 5, over x2 is going to be 1, and x1 is going to be negative 2 minus negative 2. Okay? So then we're just going to go ahead and do those ones. Negative 3 minus 5 is negative 8. Negative 1 minus negative 2 is positive 3. So we have negative 8 over 3. I'm going to go ahead and do that for the rest of them there as well. So we've got line segment RQ. We're going to have y2 minus y1, x2 minus x1 again, right? And that's going to equal y2 is going to be the y of the second point, which is 8. Y1 is going to be negative 3. 8 minus negative 3 over the x2 is going to be 6, and the x1 is 1. 6 minus 1. So that's 8 minus negative 3. It's 11. 11 over 5. Right? So we can see here, from now, we can tell that these two lines are definitely not perpendicular. Right? So there is not a right angle over here, for sure. And we just need to pick one other one now. So this is going to be line segment PQ. And if this one is perpendicular to either of the other ones, then we will be good to go. Right? And then we will know that it is a right triangle. So keep writing out my formula each time. That's going to be y2 here is going to be 8 again, but y1 this time is going to be 5, right? Because it's this 8, this 5. And then x2 is, let's see, x2 is going to be 6, but then x1 is going to be a -2. x1 is going to be a -2, right? So then we're going to have 8 minus 5 is 3. 6 minus -2 is 8. Now, what do we see? Well, what we see is that these two are negative reciprocals. Therefore, lines PR and PQ are perpendicular. So we can use this to mean perpendicular, right? That's perpendicular. So, and again, therefore, triangle, or just the symbol, triangle PQR is a right triangle. There we go. All right, so that's there's a fair bit to do on a question like that one, as we see as we go down through there. All the steps are stuff that you will have seen before, right? It's just there's a whole bunch of them put together in the one question. Slope of a line perpendicular to the segments having endpoints that. I'm going to skip that one because that's pretty similar to what we just covered. Write the equation of a line in slope-intercept form, a line that is perpendicular to the line that and passing through the point that. Okay. Interesting. Interesting. Okay. Yeah, I'll do that one. That was one of the that never mind. That wasn't one of the ones the student asked about. Never mind. We'll carry on then. We'll carry on. Change each of the following equations to general form. Let's see. Graph each of the following equations on the grid provided. Yeah. Yeah, let's do some graphing questions then. Let's do some graphing. So let's hold on one second. Okay, sorry about that. We were going to pop back over to my good pal Desmos over here. So we're going to go back to Google Chrome. There we go. Now, I'm going to go ahead and graph these lines. So the lines that we are graphing then, graph each of the following equations on the grid provided. So our first one, then part A, I'll write these nice and big so we can see it even on my zoomed out cam over here in the corner. Y plus 1 is equal to -1 over 3 x plus 5. Right? Now, how can you go ahead and just graph this one on its own? Well, if you're plugging it into a calculator like this, all you need to do is switch this to a form where it's just y equals something, and we can go ahead and graph it. Right? So on a calculator like this, like on your computer activities, you could change this one into 1 over 3 x plus 5 minus 1. And the nice thing about this form is this will work in a TI-83, TI-84, graphing calculators. It'll work in any sort of technology like this, right? But you can just go back and plug that guy in, right? And we are going to use that to see what our line is going to look like. So it's going to be -1 over 3, close the bracket, open a bracket. x, oh, what the heck? X plus 5, close that bracket, and subtract the 1. So we know that our line is going to look like this, right? And one way that we could graph this right from the start by hand, right, is by doing what I said earlier, where we know that because there's a plus 1 here, this line is going to go through a point that has the y-coordinate -1. And because there's a plus 5 here, we know that this line is going to go through a point where the x-coordinate is -5. Right? So if we look up at our Chrome window here, we should see -5 -1, -5 -1. There it is. Right? Like I said, at the zoom that I have it there, there's 2 blocks. There we go. That's better. Now there's 1 block. So -5 -1, there it is, right there. We know that that point is on our graph. So if we're doing it by hand, we can just go to our grid and just draw that point first. So let me go back over to my working display. Here we go. So we know now that we will start off, if we were to draw a coordinate plane, which I will do a attempt at over here. We've got our y's and our x's. Right, so we know that the point -5, 1, 2, 3, 4, 5, -5 -1 is going to be on there. And then we know that the slope is going to be -1/3, which means our rise is going to drop drop 1, when it goes to the right 3. So we're going to go right 3, 1, 2, 3, and down an extra 1. 2, 3, down 1 here. Let's do that again. 1, 2, 3. And down another 1, say about here. And then if we were to join those guys up, we would now have graphed our line. And we're told it's a line, so pedantic Peter will want you to have an arrow on the either end of your line. Okay. Because of course, if it's a line, it continues on infinitely. There's an arrow on either side. So then for part B is that one is a general form question, right? So let me just zoom that guy in. Zoom. So this one, like I said, that one is slope point form, which is kind of just very similar to slope intercept form, but it's not exactly the same, of course. And over here, this one is general form. Now, how do we go ahead and graph this guy? Well, I would recommend putting this one into one of the forms that's generally simpler to do graphing stuff with, right? So again, just a reminder, Brittany, I saw that you mentioned earlier you wanted help. If you're still in stream listening, please drop into stream somehow what you would like me to cover, right? And I will get to that before the stream is done. And for part B here, we start off, I'm writing this nice and big, so even when I switch over to my next cam, we can see it a little bit. This is 3x minus 5y minus 10 equals 0. So to go back to that, good pedagogical lesson that Carlene gave me, in general, knowing the fundamentals, like knowing the basics behind this, is going to help you be able to tackle a whole bunch of different questions. So even if you look at this and you say, I have no idea how I graph this guy. Well, with the algebra skills that you've built in the courses up to this point, right, those fundamentals, you can take this and turn it into a form that you do know how to graph. So because I like slope-intercept form the best, I'm going to put it into slope-intercept form. So to do slope-intercept form, we need y on one side by itself, and then that's it. Everything else is just all on the other side. So I'm going to call this now 3x minus 10 equals 5y, just like that. right? Move the 5y over. Now I'm going to divide both sides by 5, and I can get 3 over 5x minus 2 equals y, right? The algebra was not hard. That was a way simpler algebra rearranging than you would be asked in a lot of algebra courses, right? So now I can just go ahead and graph that guy over here. So minus 2, I know minus 2 is the y-intercept, so here's a point, and it's going to go 3 over 5, which means it's going to, the rise will be 3 and the run will be 5. So 1, 2, 3, 1, 2, 3, 4, 5, right here. And now I'll just take those and join them up, like so. Put those on it, and there we go. So let's just go back over to the interweb and see if that would be the right thing to draw. So now I'm going to make a new, see this symbol up here? Oh, this is a good teachable moment too. For your Desmos, there's a whole bunch of different things that this can do, but just very simply, I'm just going to add an expression here, right? So the expression is going to be 3 over 5. I gotta remember to go to the right there. 3 over 5x minus 2. There it is. There's the line that I just drew. Look at that. Seems to be pretty good. Seems pretty close to right from what I drew. Right? Now, mine was freehand, of course, so it's not exactly right. But hey, it even came up in green and blue. Look at that. Wow. Oh my God, that's trippy. That was by default. It came up in green and blue. Look at that. Mine's in green and blue. It's green and blue. Whoa. Whoa. What does it mean? It's a double rainbow. What does it mean? What does it mean, you guys? What does it mean? Okay. Yeah, what am I going to do next? Let's see. The next question, back over to the working display here. So that was question 23. Question 23 down. So the next ones, let's see, 24 and 25. Turn the slope and y-intercept of each of the following equations. Oh, well, how easy. That was what I just did. Let me zoom in, zoom in. So I'll do one of the two of these. Oh, let me just, this was still math. 1101A, no, 1101C, Unit 1. Okay. Okay, over to the side there. So now for this next guy, what do we have? So 1101C, Unit 1, and this is question number 24, and I'm going to do part A there, like so. Okay? So what we have got is a lot blurrier camera, isn't it? I had to tweak my encoding after this. See how much better I can get this camera working. 2x minus 4y minus 16 equals 0. And since we're trying to find the slope and y-intercept, well, guess what form finds us the slope and the y-intercept? Oh boy, maybe it's slope-intercept form. Maybe indeed. Okay, so I'm just going to put this in a slope-intercept form, which means the y is by itself and everything else hangs out together. 4y moves over, divide both sides by 4, 1 over 2x minus 4 equals y. We're done. That's it. The slope, 1 over 2. The y-intercept, -4. Easy. Or if you want to be really precise, -4 comma 0. I would mark either of those right. -4 or -4 comma 0. Both fine. Okay. Yeah, I'm not going to do 24b. I think that's probably simple enough to see how you do 24. 25. The vertices of a quadrilateral need to be zoomed out. Vertices of a quadrilateral, ABCD, are -4, 2, -2, 3, 4, 1, and 0, 11. Algebraically determine if the quadrilateral is a trapezoid or a parallelogram. Explain your choice. Okay. So what we're going to need to know here is how many of those sides are parallel. And what do we know about parallel lines? Well, for 25 here, parallel lines have the same slope, right? Up on page 68, number 2, page 71, number 1. Yes, Esther, yes, you were indeed. And this is the last question I'm doing on this topic, and then I will get on to your one next. Yours is on the list next. Okay? Hmm. Chewing noises. That makes for good, that's really good radio, let me tell you. Like, just, I mean, that's what I imagine like the social eating kind of thing on Twitch is, right? Like, just sort of like chewing noise, like an ASMR chewing noises stream. I don't know if my audience are the ones that are into the ASMR. I'm not, but I'm aware of it. Uh, okay. So, what I would recommend doing, I always recommend when in doubt, draw it out, right? I should like put that on a t-shirt. Well, what I recommend doing normally is when in doubt, cut it out. That's a good cross-curricular lesson there. When in doubt, cut it out is my favorite phrase for editing. Oh my goodness. The amount of like editing is so much harder than writing, to be honest. Like writing is easy, editing is work. Or like the Mark Twain quote, right? Writing is easy. All you have to do is cross out the wrong words. That's it. That's it. You're just, write drunk, edit sober. That was a Hemingway. Fitting. Um, but yeah, when in doubt, cut it out, right? When you're editing, if something seems like it doesn't fit, if you can't get a sentence to work, hey, maybe you could just do without it. You can just do without it entirely. But in math, when in doubt, draw it out. So A is 1, 2, 3, 4, 1, 2. So A is going to be over here. B is -2, -3. So it's down here. C is 4, 1. 1, 2, 3, 4, 1, right there. And D is 0, 11. 0, 11? Are we for real? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 0, 11. Kind of up there. So, holy moly. Now, we can't take the way it looks as being all that important here for us, right? But I gotta say, after drawing it out, I'm not super hopeful that this is going to have two pairs of parallel sides. I gotta tell you. Gotta tell you, this guy is looking like a trapezoid, not a parallelogram to me. But, hey, I did draw them a bit off, right? This is freehand, so we can't go taking this as gospel. But, like I said, when in doubt, draw it out. Okay. But we know now the four lines that we're going to have to find the slopes for are going to be segment AB, segment BC, segment CD, and segment DA, or AD, however we want to write that one. Right? So then segment AB, right? The slope y2 minus y1 over x2 minus x1. That one is going to be, so the y coordinate of b is -3, y coordinate of a is +2, x coordinate of b is -2, x coordinate of a is -4. Like so. -3 minus 2 is -5, -2 minus -4 is +2. Okay, so now we got BC. I'm going to stop writing line segment. I'm going to streamline this a little bit. So y2 is 1, minus y1 is -3. X2 is 4, and x1 is -2. That's going to be -1 minus -3 is going to be 4. 4 minus -2 is going to be 6. And that's going to equal 2 over 3. Right? And that seems to check out based on what we can see here. So now we're going to go segment CD. Segment, how's about I call it segment DC instead, right? Because I like going from left to right for all these ones, which is one reason why I wanted to draw it out, just so we know that we're taking our line from left to right, because that is sort of the way that it's set up here, right? So y2 is going to be 1, y1 is 11, x2 is going to be 4, and x1 is 0. So that's going to be -10 over 4, which is -5 over 2. Hey, look at that. Look at that. We already know now. Parallel. Hey, look at that. So we know that line AB, segment AB and segment DC are indeed parallel. Let's see if this one is parallel to that. I gotta tell you, I'm not super hopeful that it's gonna be, but we're gonna try and see. So segment AD is going to be equal to y2 is 11 minus y1 is 2, and then x2 is 0 minus x1 is -4. So now what we have is 11 minus 2 is 9 over 0 minus -4 is +4. 9 over 4, is that the same as 2 over 3? Right, that is not parallel. So if we have two parallel sides and two not parallel sides, we know that quadrilateral ABCD is a trapezoid. Okay, because it has one pair of parallel sides. All right, that's good. Good stuff. It's Math 1101C done. Betty Ann, I hope that was enough to give you a good idea where you're going with those guys, right? I tell you what, their Twitch stream. Tell you what I am going to do. Please, actually, no, I'm going to, because of the way I've been running the stream, I'm going to carry on. And any sort of tech support stuff to try to make this camera a bit better, I'm going to do afterwards. So now, Esther, yes, you want page 68, questions 2, and page 71. Okay, sorry, getting emails and stuff. All right, so here we do, up in the corner here now. I have, yeah, a nice digital version of one of the textbooks that we're using here. So Esther, I'm going to be able to scroll on down now to page, I think you wanted page 68. Page 68, question number 2. So here it is. Oh, good. Good stuff. Okay, yeah, this is practical. This is practical to tell people, because the book doesn't do a super great job of explaining these ones. Oh, I thought we were drawing stem and leaf. No, we're not drawing stem and leaf. We're doing the mode of each data set. Hint, rewrite the stem and leaf plot to place the values in ascending order. Wonder how math teachers can help in fighting COVID-19. Well, I tell you what, I can help by helping my students learn uninterrupted while the outbreak is going on. That's what I can do. And yeah, I think I'm doing as much as I can for that, and I'm super grateful for everyone who's along for the ride and listening, responding, asking questions. Yeah, it's great. And of course, anyone, any random Twitch viewers too, you want to ask some questions, feel free. If you're trolling and just trying to stump me, I'm going to leave it till last, you know. But if it's a genuine, good faith question, I'll get to it the same way as I would my class. Integrated curve. Oh, sure, sure. Want me to do some integrals? Integrals are actually past what I cover in these courses. I can do integrated gamma curve. That one I'm not aware of that one. I'll have to brush up. I'll have to do a Khan Academy brief on what that means before I get to that one. So let's see. This is Math 3102. 3102, and This is Unit 2. So, determine the mode for each data set. Oh, I've got more. What is going on? Oh my goodness. No, that's just a weather notification. Boy, weather notifications seem a little less severe these days, don't they? Right? Like, oh no, maybe there's snow coming. Maybe schools are going to be closed. Okay, so this is question 2A. Determine the mode for each data set, rewrite the stem and leaf plot. Yeah, so let's do that. Let's rewrite the stem and leaf plot. So stem and leaf over here. Draw this guy down through here. Now, a stem and leaf plot by rights should have a key. I was always told that you always need a key with your stem and leaf plot. Now, what does a key do? Well, what does a key do? A key do? A key do? A key tells you how to read a stem and leaf plot. So for here, for example, we have a 1 here and a 0 here. So our key tells us how to read it, so that 1 bar 0 is equal to 10. That tells us that these are the tens digits and these are the ones digits. I know over here they did write tens and ones out. Oh, let's see if you can see my cursor. There we go. Yeah, so they wrote tens and ones out over here, so I guess they kind of didn't need a key, but you should still have a key. Right? So I'm going to write these in order. 0, 2, 5, 8. 2 is going to be 0, 0, 1, 9. 3 in order, we're going to have 1, 2, 5, 5, 6. 1, 2, 5, 5, 6. And then 4, we're going to have 0, 4, and 5. All right, so that tells us in order what all the numbers are that we're dealing with. And of course, then, oh, Betty Ann, if there was a trouble sending messages in chat, that was probably maybe you weren't logged in. I'm not sure. Either way, thanks for sticking around and watching. I hope that helped you. So Esther and anyone else who's currently wondering about the mode of this data set, the mode just means the most common number. But it's important to know that unlike, say, unlike median, there can be more than one mode. So the mode here is any number that comes up the most number of times. But if they all only come up once, don't say that the mode is every single number. The mode is just, there's no mode then. But if some numbers come up more than others and they're tied, then those ones all meet up. Hey Russ, thank you. Thanks for dropping by. Yeah, appreciate that. Just yeah, if you know anyone who might need some math questions, feel free to send them my way. But yeah, thanks for stopping by. So here we see that there's two 20s and there are two 35s, right? Because there's two 20s here. Let's underline those in a different color. Two 20s here, two 35s here, right? So the mode of this set is going to be 20 and 35, right? So then for part B is pretty similar, although it doesn't have the stem and leaf plot part there, right? So we've got frequency. So what frequency does is it tells us basically how many times these things show up. So say size and frequency. Say this was like the weekly sales for a shoe store or something like that, right? So what this tells us is the shoe store sold, let me get my cursor there, there we go. Sold 12 size 6s, 21 size 7s, sold 30 size 8s, 16 size 9s, and 8 size 10s. So what's the mode? Well, all you got to do is read off from there which one's the most common. So here, the mode, pretty simply, is 8. Because it is the most common. A situation like this is a good point to make because on your tests and stuff, sometimes you will see questions about like which measure of central tendency is the most relevant, right? And if you're talking about like a store selling something, then the mode is the most relevant because it doesn't really matter what the average size that you sell is, like the average number of the shoe size, because you're not going to order like, 7.82 size shoes, right? But you are going to need to know which one sold the most because you're going to need to know if you got to order a whole bunch of 8s and not so many 9s or whatever. So, page 71, question 1, I think was Esther's next question. Let me zoom out a bit so I can make sure I'm on the right page. 69 and 71. You did it, Reddit. You got there. Okay, so we're on question 1. Find the median for each data set. All right, okay. And these are the notes questions. So for the notes questions, because you're not over social distancing, you're not going to be graded on these ones per se. You do have the answer keys, though. The answer keys are in the backs of your books. But for notes questions like this, I will answer, every single one of those. As you noticed earlier for that other activity, I was skipping some. But here now, I'm just going to go ahead and do the lot. So the median for each data set. First up, to find the median, you have to put the numbers in order. So I'm going to put that down here in capital letters because that's the only thing that people tend to mess up on. Not saying that anyone specifically will, but I've taught enough students that you see some errors a lot more than others. Put the numbers in order, right? So that's going to be, let's see, 19, 19, 20, 21, 22, 23, 24, and 24. Once we have them in order, then it's actually super easy to go ahead and to get our median. The median is just the middle number that you can count and see, or what you can do is this thing we do. Let's see, yes, we do n plus 1 divided by 2. This tells us which number is the median. And then n is the number of numbers. N is the number of numbers, right? So here, how many numbers do we have? Oh, we've got 8. Right, so we're going to have 8 plus 1 over 2 equals 9 over 2 equals 4.5. So 4.5 implies that the median is the average of numbers 4 and 5 in order. Numbers 4 and 5 in order. It's got to be in order. Right? So the average number is 4 and 5. Number 4 is 21. Number 5 is 22. I already know that the average of that's going to be 21.5, but I'll show you how we would do that. We just add them together and divide by 2. So that's going to be the same as 43 over 2, which is going to be 21.5. So there you go. That is your median for part A. We skip to another piece of paper. Oh, I'm running low. I don't have any padding behind it. Excuse me. So this math 3102A, yep, 3102A unit 2. Send me the notes, please. Yes, sure. I can, students in my class, I can send you the notes after class, of course. Today might be a bit longer because I do intend maybe to play some video games because this is Friday. I think maybe after the stream is over, I'll take it down for a minute and then bring it back up with a game that I'll play for a few minutes. I think I'm gonna do. I think I'm gonna do the Long Dark today. I'll talk about that a bit afterwards. But yeah, I sort of live that game recreationally whenever I can, whenever I go to the cabin. So it's a pretty apt one for these trying times in which we live. So 1B. Sorry, I do have to. Okay. It's probably a waste of breath for me to say this on stream because anyone who's watching already knows, but I'm not going to be answering emails while on stream. I can see them. So if it's like something majorly, I don't know what major emergency you would have though. Like if your dog ate your homework and you've got a video of it, like do send me that, but I'm not going to watch it right away. I'll get it later. So here now, I'm going to put the numbers in order first. But, oh, actually, no, in here we're already in order. Oh, wonderful. Look at that. Look at that. Don't even really need to write it out. But I'll go ahead and do it anyway. So I have it here to write on. So remember, to get our number of which one is the median, we had to do n plus 1 over 2, where n is the number of numbers. Right? So how many numbers are here? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 plus 1 over 2 equals 14 over 2, which equals 7. So it's just the seventh number in order. That's all. 1, 2, 3, 4, 5, 6, 7. Median is 13. All right. So then for C, we're going to do a similar kind of thing. But how many numbers do we have? N equals what? Well, there's 1 here, 3 here. Are we seeing this? Are we seeing my cursor? No. There's 1 here, 3 here, 8 here, 9 here, 2 here. So it's just going to be 1 plus 3 plus 8 plus 9 plus 2. So then n is going to equal, it's 4 plus 8 is 12, 9 is 21, so it's 23. It's going to be 23 different guys there. So then, to get our n plus 1 over 2, that's going to be 23 plus 1 over 2, 24 over 2, otherwise known as 12. So it's our 12th number. So we go back over to our frequency, and we say, well, which one's the 12th? Where there's 1 there, 2, 3, 4 there, 5, 6, 7, 8, 9, 10, 11, 12. 12 is going to be a 60. So we know that median equals 60. That's it. That's how you find the median of those. All right, I also wanted to go over, let's see, while I've got you here, Esther, I wanted to go over a few different ones. Let's see, 3102A, there we go. Let's go over numbers, over a few of the multiple choice from this guy. Actually, some of the other questions on this same activity I went over yesterday at the end of my last stream. So when I send you when I send you the video, I'll actually be sending you two videos this time. A link to today's and a link to yesterday's. So you can see what I've been blathering about. Let's see. Minimum allowable height of a step is 120 millimeters. The maximum height is 160. What is the expression for the tolerance? Okay, so let me bring this back over. This is math 3102A. And now we're back on unit 1 briefly. Okay? But so now this is question 3. But it tells us that the minimum is 120, the maximum is 160. So what's the tolerance expression? Well, we know that the tolerance expression is going to be halfway in between the two of them. Actually, let me switch back over to this cam. And I have to move this over because I had that positioned differently so that we could see Smokey at the start of my stream. My little fuzzy buddy. So here now, we're scrolled over. Right? So, question 3 then. The minimum allowable height of a step is 120. The maximum is 160. And for whatever reason, I've got this weird line in the middle of my stream. Look at that. I don't understand why there's that line in the middle of the stream where there's that little bit missing. You guys see that? That's infuriating. It's right over the question. It's not like that on my OBS. It's not like that on the videos I record. It's just like that on the stream. I don't know. I don't know what's going on. Gotta fiddle with that after. Any Twitch wizards in chat know what the solution to that is? Anyway, what we have to do when we're doing a tolerance expression like this is pick the middle number. The middle number in between is the one that's in the tolerance expression. So once I'm back over and we see my cursor, there we go. We're seeing my cursor. Right? The minimum is 120. The max is 160. What's halfway between those two? It's 140. So we know the answer's got to be C. It's got to be C because we know that the middle number is the one that we're looking for. Okay? Question 4, the probability of rolling a 4 on a 6-sided die. Well, again, like yesterday, let me break out my my beautiful dice log. Look at that. Yeah, that's good stuff. I'm going to use that whenever I can. It's a good prop. And a click. Listen to that. Man, let's just try to get it all at once. Ah, there we go. So the probability of rolling a 4 on a 6-sided die, let's find out. 0. 0. 0. 0. 0. 0. All right. So the probability of rolling a 4 on a 6-sided die is 0%. It's actually not. There's one 4. There's one 4 on the die out of 6 options, so it's going to be 1 out of 6. And that is answer A. Next up. 5, 6, 7. Okay, so 5. The odds for drawing a club in a deck of cards. Now, generally, indeed, we do see odds written as a ratio, right? You can sometimes write odds as a fraction. I tend to prefer writing them as a ratio. What are the odds for drawing a club in a deck of cards? Well, odds, as we know, if it says odds and doesn't say in favor or against, you assume it's in favor. Odds in favor, well, there's odds in favor is favorable, unfavorable. Right? So here now, what we have is the favorable chance to draw a club is going to be 13. Unfavorable is going to be 39, because that's all the ones that are clubs, and this is all the ones that are not clubs. Oh, did I just oh no, I'm still here. Okay, my internet just I just dropped a few. Whoa, my internet just lagged a bit. Thanks, Rogers. One of these days, I'm going to get on a rant on this stream about how the internet needs to be a public utility. Because let me tell you something. Like at a time like this, like there is nothing that people are depending more on than the internet. But I'm going to try to keep the political rants out of here. But yes, thanks, Esther. Yeah, I know. I dropped a few frames there. It's my internet had a bit of a hiccup. Uh, but yeah, it needs to be a public utility for sure. I mean, the entire everything like society is just running on the internet right now. It will be for the next few months. Uh, anyway, the odds for drawing a club in a deck of cards, it reduces down to 1 out of 3. Or, I mean, you can write it as a fraction of 1 over 3. But here we know that the answer then is B. Okay, question 6. I've been forgetting to alternate my RGB. Question 6 was the probability of an event if the odds against are 4 to 6. Well, we know that odds against is unfavorable to favorable. We know that probability is favorable over total. So here, now we know that our second number is the favorable because it's odds against. So if the second number is the favorable, we know that the probability is going to have a 6 on top. Total is just the two of them added together. It's a 10 on bottom. And that then reduces down to 3 over 5. So we know that the answer here is B. Okay. Numbers, let's see. How many more did I want to do here? 7, 9, and 10. All right. So number 7 over here then. 42 chances up at bat. Joe has hit 7 home runs. Do you guys see that like break in the middle on the Twitch? Like, holy moly, what is even happening? Oh boy, oh boy. Let me jump back out of that view and back over into this view. And okay, so here we're not seeing it. So, all right. In 42 chances up at bat, Joe has hit 7 home runs. What's the probability that he will hit a home run next time he is up at bat? Well, so basically what we have is an experimental probability. So the experimental probability that Joe is going to hit a home run is going to be 7 out of 42. So this is what we've been told. So based on this information, what's the probability he will hit a home run next time he's up at bat? Well, it's going to be the same. It's going to be the exact same. So how do we turn this into a probability? All we got to do is break out our nice friend, TI-84, and go 7 over 42. Gives us that. We're going to times that by 100 because that's a decimal and we want a percentage. We're going to get 16.7, or rounds to about 17%. Approximately equals, I'll use a squiggle, which equals 17%. So that is answer C. Right, and then I want to do, yes, 9 and 10. So number 9, let's go down to the next page. You flip a coin once and get heads. I flip it a second time and get heads again. The probability of getting heads when you flip the coin a third time. What indeed? Well, guess what, folks? Coins don't think. All right? Coins have not got any memory. They don't remember shit. I mean, they don't remember anything. It's a G-rated stream. You flip a coin, doesn't matter what the previous outcome was, it's still going to be the same sort of outcome the second time. Let me pull out one of these random coins that I've got here in my drawer. I've got this fancy, what's this, a John A. McDonald commemorative toonie from 2015. All right, there we go. That one came back heads. That one came back heads. So I flip it once and get heads. Good, I got that. Flip it twice and get heads again. I did it. Actually, no. Both of these sides are heads because there's a John A. McDonald head and a Queen Elizabeth head, right? So this is a cheating coin. This one's going to be heads no matter what I do. Let's put that one back in the drawer. I'll save that one for the future. Here's a commemorative quarter. This is a good one. This is ultra Canadian. Look at that. It's got the Queen. It's got the Queen, Her Majesty the Queen on this side, right? We're a bit blurry. You can't see QE2 very well here. And on this side, the most Canadian object in the history of the country. You see if you can get that a bit better. That is the Stanley Cup, obviously. Okay, so let's try this one. Heads. Okay, one heads. 2 heads. Perfect. Okay, that's what I was looking for. So now this next flip will decide. Okay, we've got tails, so that means it's 0%. Is that right? Is that right? I got tails, so it's of course not. It's just another flip of the coin. It's just another, every flip of the coin is independent. They're always independent, which means the probability is going to be 1 out of 2, or it's going to be, oh, this is not question 8, this is question 9. It's going to be C, 50%, right? That's a pretty good prop too. Hey, look at that. What year is that from? 2017. In 2017, the Stanley Cup was 125 years old. Hey, go figure. There you go, right? A little bit of hockey trivia for you on this math stream. It is just called hockey, by the way. Right? If anyone calls it ice hockey, they're not from Canada. It's not called ice hockey, it's just hockey. Right? If you play it anywhere else, then you say the name. Field hockey, sure. Floor hockey, sure. Street hockey, sure. But ice hockey, no, it's not. It's just hockey. Everybody knows that. Come on. Question 10. Lucy manages a produce store. When ordering apples, she expects that 15% of the apples will arrive spoiled. If she orders 350 apples, how many apples would she expect to arrive spoiled? So I just got to find 15% of 350, that's all. So we need 15% of 350. Now this is a good lesson because it lets me point out how these symbols translate into math symbols. Right? Percent, per is literally divide, cent is 100. Of means multiply, 350 means 350. And is equals. So 15 over 100 times 350. Easy stuff. So over here, I'm going to do 15 over 100, which is going to be 0.15, of course. I'm going to times that by 350. I'm going to hit enter. Then I'm going to get 52.5. Generally, we wouldn't say that she's going to get half a spoiled apple. So our answer here is going to be B, which is 53. Okay. All right, Esther, that was the topics that I was going to cover for you today. I hope you found that useful. I know the video is a little blurry, but please do bear with me here. I will do what I can to improve the quality of this webcam, up to but not including going to Best Buy. Maybe I'll order something from Wish.com. It's a bit too real. It's a Simpsons episode, right? You guys know what I'm talking about. I don't need to belabor the point. Now I'm going to switch over to Math 3101A. So, real Bert Einstein, if you are still in the chat, good to have you here. I'm glad that a man of your caliber is hanging out. But also, I'm going to cover some questions for you here. For you? I'm going to go pour vous here now. So, let me scroll on down to 101A. We're going to do questions 9 and 12 first. Let's do 9 and 12. Now again, over the time of social distancing, I'm going to have to be making up like different examinations for different students. It's a real, boy, it's a real time sink, let me tell you. Anyway, so we're going to start with question 9 here. How many ways can letters in the word factor be arranged if you must start with a consonant, FCTR, good, and then with a vowel, A or O? Great, this is a well-written question, actually. Whoever made this activity up, good job. Gold star. So this is Math 3101A, and this is question 9. So, factor, F-A-C-T-O-R. 6 letters. So you must start with a consonant and end with a vowel, right? So if we're starting with a consonant, how many different possibilities are there up here, right? So starting with a consonant means there's going to be 4. F-C-T-R are going to be here, right? You must end with a vowel, A and O. So there's two vowels that could be here, right? But then the rest of these can be any letter at all. But how many do we have left over? Well, we don't know which um, consonant is going here. We don't know which vowel is going here, but we do know that it's two letters. Whichever, there's only one letter going to fit here, only one letter going to fit here. So no matter what happens, there's going to be two letters taken out of the word factor. The word factor is 6 letters long, so there's going to be 4 letters left over for this one, 3 letters left over for this one, 2 for this one, and then 1 here. So all we're going to do then is just multiply these suckers together. So get our pal. 4 times 4 times 3 times 2 times 1 times 2. I'll even write in the 1. I'll take you the extra mile. 192. So we see that the answer is 192, or C, 192. Okay, next up, I'm going to cover question 12. Question 12 then, let me scroll down. A teacher has 5 different math books. I got more than that right behind me. How many ways can any 3 of them be arranged on a shelf? Okay, so what are we going to use here? Are we going to use, this is the kind of question that I think you can probably tell that we're going to use NPR and NCR. But the reason we know we have to use NPR or NCR is because we're not using the full group, right? If we were taking all 5 of them and just arranging all 5, we could do just 5 factorial. But we're not taking all of them. We're taking only a set. And then, so that means we know we have to use either NPR or NCR. Then we have to say, well, does the order matter? Well, I mean, let's see, does it? Say I had these 3 books. These 3 books right here. Math at Works, the maths at work, 10, 11, and 12. These guys. So if I organize the 3 of them this way, or if I organize the 3 of them this way, they're the same books, but is that going to look different on the shelf? Is it? Of course it is. Of course. The order of arranging them is going to make them look different. So if the order of arranging them makes them look different, we know that we are using, which one? We're using P. So we need to do permutations. NPR, National Public Radio. There we go. Dead air, dead air. So all we have to do is NPR. We can plug that one into our calculator buddy over here. Or if you don't have a calculator that can solve this guy, we know that we can write out, oh, well, we can't do NPR. We can just put in NP and R. Right, we have to know that we have to do here 5P3 because there's 5 guys and we're P'ing 3 of them. So R factorial over N factorial is N factorial over R factorial. Sorry, what am I saying? N factorial over N minus R factorial is P. So that's going to give us 5 factorial over 2 factorial. Right? Which is going to work out, let's see. So 5 math P3 60. Easy because it's 5 times 4 times 3. Yeah, I should have known that. And that's going to equal 60. So for question 12, our answer is going to be A, 60. Okay, the next one I am going to do is question 17. Question 17. Scroll on down here. Chess club in high school consists of 7 members. Oh, boy, oh boy. I'm going to have to mute my stream. Hold on a second. That was my doctor. All right, there we go. There, yeah, I had an appointment for Monday. It was scheduled ages ago, and of course, we are now doing phone consultations and not, not actually going to be going in. So, everybody, we all back? We all hear me good? Okay, sorry about that. So question 17 then. A chess club in high school must consist of 7 members. The exactly 4 level 3 students, exactly 2 level 2, and exactly 1 level 1 student. If there's 10 threes, 12 twos, and 8 ones, how many different chess clubs are possible? Okay, let's zoom in a little. So, with these ones, because it's a multiple choice question, we do have a little bit of metagaming that we can do to try to answer this guy. So let's go ahead and let's play that game, shall we? Let's see what we can deduce based on the options that we're given. So 4 level 3s, 2 level 2s, and 1 level 1. Which one here is choosing 4, 2, and 1? Well, just B and D, right? We see that A is just 30, choose 7. C is 30, permutations of 7, right? We know that it's not just 30 and then we're picking 7 because it does need to be specific. So right from the start, we know that A and C are right out, right? So then, and these ones are the same except for C and P. So all we've got to figure out here now is does the order matter or not, right? Well, if like um, Kimmy, Timmy, and Jimmy are chosen, or if Jimmy, Timmy, and Kimmy are chosen, is it the same 3 that are going? Yeah, of course it is. It doesn't matter. It doesn't matter who we pick first, right? So because the order that we choose the club members in doesn't matter, we know that our answer is going to be B. There we go. All right. So that is question 17. Now let's do scroll on down. I want to skip on down a whole bunch. We're going to look at question 27. Okay, question 27 is a real good one to go over. Yeah, yeah, for sure. Um, this one's going to take a bit of writing. So no, I got enough room on the paper. Zoom out, zoom out. We go. No, zoom back in a little bit more. We can zoom in a bit. So the first 50 customers at a movie theater on Saturday night were surveyed about the types of movies they liked. Draw a Venn diagram and determine the number of people who liked horror and comedy, but not sci-fi. So basically, we're just going to draw the full Venn diagram for this situation. So let me just zoom in real nice and close on the info that we're given. Okay, so I'm going to use blue to mean horror. So let's see, this is going to be question 27. I'm going to have a blue circle for horror. Okay. I'm going to have a red circle for sci-fi. Red circle. There's a convenience store next to the house I lived in as a kid that was called a Red Circle. And I did indeed rent sci-fi movies from it. Look at that. Boy, trip down memory lane for me. And then green is going to be comedy. I guess comedy is better with green, I suppose. Not true. Not absolutely not true. Especially not performing comedy. Let me tell you. Let me tell you. Don't want to be addled up there on the stage. I've not. It's not. Anyway, rambling. 25 liked horror, 23 sci-fi, 21 comedy. Now the thing is, we can't just plug in those numbers here. That's not going to get us the right thing because it tells us this whole green circle, for example, makes 21. This whole blue circle, for example, makes 25. Right? Um, 3 liked all 3 types of movies. Okay, good. So now we've got some place to start. We start from the middle whenever possible. Right? So if 3 liked all 3 types, we now can start sort of radiating out and figuring out the other ones. 14 liked horror and sci-fi. So horror and sci-fi is going to be this whole almond-shaped one here in the center. So this whole section, counting this part and this part together, make 14. So here we need 14 minus 3, or we need 11 up there. Seven like sci-fi and comedy. Sci-fi and comedy is this sort of lump here. That makes a seven. So we grab a four down here. Let's see. Horror and comedy. Horror and comedy we don't know yet, right? That's right. Yeah, we don't know that one yet. Four didn't like any of the three types of movies. Well, we can put four outside. There's going to be four curmudgeons who just don't like movies or whatever. Maybe they only like documentaries. That's fine. Documentaries are nice. Watch, I think it's still on Netflix. Watch Werner Herzog's Happy People. That's some homework for you for the weekend. It's a great doc. Um, yeah, and that'll tie in well with The Long Dark, which I might play after stream. So anyway, that's some homework for you. Watch Werner Herzog's Happy People. It's a wonderful documentary about people who live, trappers living in central Siberia. It's quite it's quite a nice way to spend 2 hours or so. Okay, we know that 23 liked sci-fi movies, so that means this whole red circle, everything put together in here has got to make 23, right? So we've got 11 and 3 is 14, another 4 is 18. What more do we need to get to 23? Well, we need 5. Right? So we know we need 5 over here. Now, these are the 3 that we're unsure about. We don't know how many go here. But what we do know is we do know the whole blue circle. We know the whole green circle. So I'm just going to call this X because this is an unknown amount that I don't know yet. Right? And I know 25 like horror in total. But there's 14 here. So that means there's 11 left over. So this is 11 minus X. Right? Because 11 plus 3 gets us our 25. And then we have to subtract this X because otherwise we'll be over the amount that we know. And for comedy down here, we know this full circle is going to make 21. So this is 7 here. 21 minus 7 is 14. So this guy here is going to be 14 subtract X. So the one last part of info that we need to know is how many people were surveyed in total, right? And the total is going to be 50. We know that our total is 50. So down here now below, we can start plugging in the values that we're going to need. So we have got 50 is going to equal all of these things added together is going to make us 50. So I'm going to add the constant ones first and then do these 3 after. So it's going to be 11 plus 3 plus 4 plus 5 plus this exterior 4. I'm going to put that one in there as well. Plus 11 minus x. I'll put that guy in a bracket. Plus x plus 14 minus x. I'll just put those in a bracket to show you kind of where they're coming from. But now I can go ahead and just put all this together, and what we've got now is an equation with only one variable. An equation with only one variable, hey, guess what? We can solve that. So we've got 50 equals 11 plus 3 is 14, plus 4 is 18, 5 is 23, plus 4 is 27. 27 plus another 11 is going to be 38, plus another 14 is going to be 48, 52. So we have 52 here. And then we have a negative x, a positive x, and a negative x. So it's going to be 52 minus x. Because we've got 2 negative x's, 1 positive x. Okay, so now we can just switch these guys around. We'll get x equals 52 minus 50, or of course x equals 2. So now if I wanted to, I could go back and I could fill it in up here. I'll do that in a different color. So I could call this one then 2. I could call this one then 12, and I could call this one then 9. So now we're done. Right? Determine the number, use a Venn diagram, determine the number of people who liked, oh, I need to zoom out, not in. Number of people who liked horror and comedy, but not sci-fi. You need to zoom out a little more. Little more. Okay, little more. Little more. Okay, so what we want is we want the number of people who liked horror and comedy and not sci-fi. Okay, yeah, I know. We just Okay, sorry for the drop frames there again, folks. Yeah, welcome back. I'm going to have to my internet is not cooperating very well. Boy, oh boy, Rogers is uh, Rogers is not being kind to me today, are they? My kilobytes per second have dropped substantially. Uh, yeah, wonderful. Okay, so for Monday's stream, I'm going to have to. Boy, oh boy, it keeps. Okay, this is ridiculous. This is ridiculous. Uh, wow. I'm just totally at the mercy of this, aren't I? I'm just totally at the mercy of this Rogers internet right now, and it is messing me up. Let me tell you what. Boy, oh boy. Don't they know that this is exactly what I talked about earlier. This is a public utility now. It really always has been. Now yeah, I'm still dropping those frames. Um, can't change my video frames per second output live, apparently. Let me try to change my kilobytes per second, ratchet that down a touch. See if I can get this to cooperate at all. It might look even a little bit blurrier now. I've just ratcheted down my kbps again. Um, Hopefully this allows me to sneak under whatever minuscule amount of bandwidth I'm pulling down. Holy moly. All right. Well, Bert, if you're in chat there still, this is how we answer question 17. Hope you didn't miss too much of that. Let me just put that guy aside. So, Brittany, yes, if y equals 7 and w equals 11 and x equals 0, then what does that do? 7c7, is that how? Yeah, exactly, exactly, right? Because you're just going to add the two ones in the bracket together first, right? So you're going to have your w plus x is going to equal 11, then you're just going to have your 7 times 11 is 77. Yeah, that's exactly right. Okay, so this is still going to be math 3101A. This is going to be, let's see, we're going to do question 27. How long am I in here now? 10 to 2. All right, sure, I got a few more minutes yet. A few more minutes in me. Question 27. Oh, yeah, that's the one we just did, actually. Never mind. Cross that one out. 29. Not going to do the same question twice. It's all bad enough. David rolls a six-sided die, number 1 to 6, and flips a coin, which is head or tails. Use a tree diagram to illustrate all the possible outcomes. Excellent. Okay, that's a good question. That's a good question because, yeah, partly because I can break out my props, but partly also because it's the kind of thing that you will see quite a bit, right? There's my coin. There's my die. Right, these two guys. Right, so if I roll the coin, roll the coin. Okay, if I roll the coin, it's still going to be heads or tails. If I roll the die, there's of course 6 outcomes, right? So for the die roll, there's going to be 1, 2, 3, 4, 5, and 6. Okay? So I appear to be lagging. Oh my word in heaven, I'm lagging way behind. I'm watching my stream and I'm like ages out in front and we're dropping frames again. Okay. And now coin, we're going to have heads or tails, 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 and heads or tails. Okay. I'm gonna have some serious reviewing to do of the video after this is over. Maybe I won't be doing games after. Boy, although I'll see. I'll see. If I'm dropping frames during a game and stuff, I guess I'm not going to be super concerned. Um, because unlike most most Twitch streamers, for me the game is actually just relaxation, right? The game is not the work part. So then the sample space or the results, right, are 1H, 1T, 2H, 2T, 3H, 3T, 4H, 4T, 5H, 5T, 6H, 6T. And there you go. That's it. Done. Right? It's a yeah, it's a super straightforward question, right? Use a tree diagram to illustrate all the possible outcomes, list the outcomes. There you go. All right, so that is a nice 2 out of 2. 2 marks out of 2 for getting just that done. So all you really got to do is draw out the diagram, right? That's question 29. Let's see question 31. See question 31. Hopefully you guys are still keeping up on the stream there. We are back, according to OBS, to being in line with the bit rate that I asked it to put out. Please, Rogers, just let's get some bless RNGs. How about we get some bless RNG in the chat? Huh? It's actually not RNG because RNG implies that it's within a video game. But I mean, I still think that the emote is pretty apt, isn't it? The bless RNG. It's good. Maybe I'll get my first chat emote to be like Mathman Bless or something like that. Anyway, 31. Algebraically solve for n. Oh, this is a good question. This is a really good question. All right, this is a good one to look at for this unit because this is the kind of stuff that you got to do all the time. Yeah. Algebraically solve for n. Oh no, zoomed in too far. There we go. So we've got n p2 equals 42. Some number p2 equals 42. Easier questions wrong and the harder ones right. Yeah, that's pretty much exactly what happened. Yeah, it is. It sure is. Yeah, and yeah, you'll see now, Albert, how long it took me to respond. I saw that message like the second you typed it, and that's just how much my video is lagging behind now because of this internet malarkey. But anyway, I'm going to power through until the end of this stream because I don't want to take the stream down until we're done. And then I'm going to take it down and see what I can do. Anyway, so in PR, we know that n PR is equal to n factorial over n minus r factorial, right? So here we know that n factorial over n minus 2 factorial is equal to 42, right? But how can we rewrite this, right? N factorial can be rewritten as n times n minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5. So it's all the way down to 3 times 2 times 1, right? I'm going to put my equals 42 over here because I ran out of space. And then n minus 2 factorial, that can be written as n minus 2 times n minus 3 times n minus 4 times whatever, down to 3 times 2 times 1. And of course, Bert, you've seen this stuff before, so I didn't need to write this out for your sake, I am sure, but for some of the other people watching, it might be illuminating to know why these cancel. We can cancel this whole lot now with this whole lot here, because we see we've got the same thing on top, same thing on bottom. If you got the same thing on top and bottom, you can just get rid of a lot of them. So now we have 42 equals n times n minus 1. We can FOIL these guys, right? 42 is going to equal n squared minus n, or 0 equals n squared minus n minus 42. Now there's a whole bunch of ways, that we can solve this. I'm going to try doing decomposition method. So what I'm going to need is I'm going to need two numbers multiply to -42 and two numbers add to -1. And what could they be? What could they be? Well, we've got our 42 just in general, right? It's 1 times 42. Well, that's not going to work. 2 times 21. It's also not going to work. 3 is going to be times 14. 14 also not going to work. 4 is not going to go in there. 5 is not going to go in there. 6 times 7. Hey, look at that. Yeah, now we're getting somewhere. These guys are indeed 1 apart, but it needs to add to -1, so we know the bigger one is negative, so it's going to be a -7. So now what I'm going to do is I'm going to go back over to here. I'm going to take this and put it in up there, right? Let me just slide my sheet up a little. So I'm now going to call this 0 equals n squared plus 6n minus 7n minus 42. Because, of course, a -1n is the same as a plus 6n minus 7n, right? If I put these back together, I would get back to this. So really all we've done is organize it differently. We haven't actually changed the numbers. 0 is going to equal, and then we're going to factor out what I can out of these pairs. This pair here, and then this pair over here. But don't worry about those brackets. Those brackets I just put in are not really there. I'm just doing that for illustration's sake. But now we're going to have an n outside of n plus 6. And now I can, because n's the biggest thing, I can factor out of n squared and 6n. The biggest thing I can factor out of -7n minus 42 is going to be a -7. It's going to be outside of n plus 6 as well. Hey, look at that. So now we have 0 equals n plus 6 times n minus 7. Right? So that means that our roots for this equation, are anything that make this true, right? So this is true. 0 is equal to n plus 6 times n plus 7. If this bracket is 0, or if this bracket is 0. For this bracket to be 0, n plus 6 equals 0, which means n equals -6. For this one to be 0, n minus 7 equals 0, n equals +7. And we know, because our beginning was an NPR situation, you can't have -7 pick 2, right? Because you can't have like -7 options and then choose 2 of them. What the heck is, sorry, -6. You can't have -6 options and then pick 2 of them. So what the heck would that mean? So that one's not the answer. The answer is this one. The answer is n equals 7. So we know that it's actually 7p2 equals 42. Right? There we go. Good stuff. It's 31 down. Got one more to do on this course. Then I've got a bit to do for Renetta on Math 2018. And yeah, then I'll be cluing up by my 2:30 self-imposed deadline. So that's good. Zoom out a bit more. You know, now that I'm streaming, I would like to have, I would get faster internet, but like maybe Bell fiber op, so I wouldn't have to deal with this Rogers bull crap. But you know, not really gonna be able to have a tech out these days, now am I? So next up, we're just gonna make do, folks. We're just gonna soldier on. It's not a big deal. It's not a big deal. Just occasionally, y'all might have to put up with me like stuttering. I mean, not my normal stuttering, not, like my video stuttering, I mean. So number 32, so this is Math 3101A still, and this is number 32. So what is the probability as a percent Bob and Chris standing next to each other in considering the total possible arrangements of Bob, Andrew, Chris, Dave, and Eric? A, B, C, D. Thanks. That's good. That's good. I'm glad the person who wrote this test was on point, actually. I mean, this is not a test. The person The person who made this activity was on point, let me tell you, because they knew that people are going to want to have A, B, C, and D. So we've got five chappies, right? So the probability, we all know, probability is always favorable over total, right? So the easiest thing to do here is to first find our total, because the total is just always going to be easiest. So we know that the total is going to be, well, there's five options for the first guy, four options, three options, two option, one option. Well, that equals 5 factorial, and that equals 120. So the probability as a percent of Bob and Chris standing next to each other when considering the total possible arrangements. So our total is going to be 120, right? Because there's 120 different ways for them to stand out there. Rogers is the fastest. Oh, I don't know. I don't know. Bell Fiber Op is has got. I have heard from people that use a lot of internet that the fiber op is better as long as you get like one of the higher packages. But I don't know. I personally would love to see like a low cost public option because I mean I'm getting just internet and it costs me like 110 bucks a month. It's foolish. No cable, no landline phone, no nothing. Anyway, I don't want to be moaning about my internet costs. But our favorable now, a favorable is a bit more work because there's a situation now where we've got a set of two chappies and then the other three, right? So in our favorable situation, we've got this one here, which is B and C are together, and then A, D, and E are someplace else, right? But this one here is not just those two, right? Well, it's not just BC, it's also CB, right? So we know that there's two possibilities here, right? Because these guys can be in different orders. It's actually two factorial possibilities, but of course, two factorial is two because it's two times one. And then we have another situation, but it's not these three moving around. It's actually these four moving around, right? Because we've got this one set here of Bob and Chris. We've got this set here of what is it? Andrew, Dave, and Eric, right? But then Bob and Chris can move here. They can go there. They can go there. They can go there, right? Or they can stay at the front. So we actually have four. It's actually four dudes, four sets of dudes that are moving around. So to get our favorable, it's not just 2 factorial. It's not just 4 factorial. Our favorable is going to be 2 factorial times 4 factorial, right? So what we're going to get then for our probability is going to be 2 factorial, 4 factorial over 5 factorial, which instead of putting 120 down there, I'm going to list this out so it cancels. The Tesla's future internet service, hopefully. Yeah, please. Let's get Elon Musk in here with his like, universal 4G or whatever. That would be glorious. Yes, please. That should be everywhere. I mean, like I was saying earlier, right? The internet has very, very rapidly become a public utility, and it's insane that there aren't better, low cost, like widely available internet services out there, especially in Canada. Like we pay through the nose for telecom in this country. It's really foolish. Um, anyway, that's 2 factorial, 4 factorial over 5 times 4 factorial. So these guys cancel, and we're just left with 2 over 5. That's it. 2 over 5, or that is the same as 40%, right? So, yeah, or SpaceX or whatever it was. Yeah, yeah. I think it was. I don't know if it was SpaceX. I mean, it was some Musk related project, I guess, right? Like he would probably, if there were satellites, they'd probably be sent up by SpaceX. I don't know if it was maybe its own entity or not. But yeah, like low cost universal internet. That's really should be a priority. Maybe this whole social distancing thing will sort of uh, help the powers that be, help the political will, help us create the political will to do things like create better public internet options. But anyway, I'm already looking past it, right? We're in the midst of it. We're in the beginning, not even in the midst. We're in the very beginning and I'm already looking past it. Boy. Anyway, our probability for number 32 is just simply 40%. Right? So there we go. There we have it. So now, real Albert Einstein, that was the questions that I was going over for you. I hope that helped quite a lot. Or I hope that helped any little bit at all, really. So now, let's see, 207, Renetta, here we go. We're moving on to the things that you asked me to do, page 179. That's good. Then after, I'm also going to do page 170, I think, just to get you a bit more detail there. Unfortunately, I do not have a digital version of Prism Math Purple, or Prism Math Blue, rather, which is this one. So I'm just going to have to tell you what. I'll give you something nice to look at up in the corner. There we go. Perfect. Switch back to my little fuzzy buddy out in front of the cabin on quite a secluded little lake. Look at that. It's a very small lake, very shallow. Now, there used to be a sawmill out there. The place that my parents' cabin is on was years ago, like 50 years ago or so, was an actual sawmill. And the land around it is super marshy and like really tough to build anything on. But the only reason their cabin is where it is because that was the foundation. The area used to be the foundation of the sawmill, so it was a much better place to build on. After they bought the cabin, we jacked it up on all the sides, and we got like some big slate stones, like some bit, and put it down and under on some cinder blocks to help balance the make sure that it wasn't sinking anymore. Because the people that had built it first had the cinder blocks put down so that they were like a stencil, like the flat, like the open part of the cinder block was facing into the ground, so it was just like pushing down and cutting into the ground because it didn't have any surface area. Anyway, that's a good math lesson, right? You want to maximize the surface area from the cinder block, not minimize it. Anyway, Renetta. So the difference between blue and purple, they're just two different books that are for several different courses. Purple is for Math 2019 and 2020. Blue is for the 8 previous ones. So blue is for 2011 through to 2018. And these are some questions for 2018. So we're finding the area of triangles. Okay, let me just rearrange my physical space a little bit here so we can see what we're doing. So this is Math 2018, page 179. Okay, question 1 then is a triangle where this line in the middle is 6 meters, the bottom is 9 meters. Okay, I'm going to now move the book over a bit so that I can get myself on the flat again. That's true. Yeah, the color is different between blue and purple. You're absolutely right. So the area of a triangle, we always know the area of a triangle is a half the base times the height. Now, why is it a half? Why is it a half? That's a good teachable moment, actually. Why is it a half? Well, if we've got a triangle, any triangle is actually half of a rectangle. Because any triangle at all, if we were to double it up and put another one there just like it, we would have a rectangle. And we know that the area of a rectangle is just length times width, right? So the area of a rectangle will be the length times the width. But if we wanted to take the triangle is going to be half of that, right? So the area of a triangle is going to be half of the length times the width, or the way we normally write it, we don't write length and width for triangle, but it's the same sort of stuff going on. The area of the triangle is a half the base times the height. So that's why there's always the half in a triangle, because a triangle is basically half of a rectangle. Okay, so over here now, we're just going to do a half times the base, which is 9, times the height, which is 6, right? Which is going to be the same as 9 times 3, which is going to be the same as 27. So that's 27 meters squared. Okay, let me do a few more examples of this one. Um, yeah, I'll do the next example as well. Sorry, I don't mean to be talking away from the mic so much. I need to get, that's another thing I need to get. I need to get a nice Yeti Blue or something that I can put down from a, oh, what am I doing? That I can have from a proper, like, stand over here. Currently, you're listening to me from the microphone of my webcam, which is a reasonable microphone, honestly. It works, it works fine when I've got to be calling out if my dragonkin resisted the sleep spell in Blackwing Lair. But when I'm moving around and doing this sort of stuff, um, sometimes it's doesn't pick up the sound the same from everywhere. Anyway, 3 and 4. That's 3, and that's 4, and this is a right triangle. Knowing that this is a right triangle means that I know that the height is here and the base is here. So again, the area of the triangle is a half times the base times the height. The area of the triangle is going to be a half times 4 times 3, so that's going to be 6. Okay. Renetta, yeah, those should be enough examples, hopefully, for you to get through the rest of that one. Right? I think that you'll see how it's working there now from those. I will also, just to be thorough and just to make sure that you've got a good background here, um, yeah, I'm going to take a look at page 170. 170. So 170 is a good page because you don't actually have to do that one. You're not responsible for it because it's a pre-test. What a pre-test means is these courses are designed to be refreshers to help you get back into it. So a pre-test sort of lets you know beforehand all the different topics that are going to be covered on this unit, right? So I'm going to pick a few different ones off of this page to cover, and we're going to wrap it up for the week. Actually, not even for the day, for the week. So find the perimeter or circumference of each figure below. So for question 1, the perimeter, well, the perimeter of a rectangle, perimeter of any shape is just the distance around the shape, right? So the perimeter of this rectangle here, if you let me go over here for a second. There we go. Let me zoom in a little bit on my buddy. There we go. That's nice. The perimeter, let me just give him a little pet. So the perimeter over here is going to be, let's see, 3 plus 12, right? Because of this 3 and this 12. But there's also another 12 and another 3. So plus 3 plus 12. Or we can imagine it as 3 times 2 plus 12 times 2. Either way, that's going to be 6 plus, oh, that's a 12. 6 plus 24, or 30. There we go, 30 centimeters, right? For a square, again, prism math. You're bust my balls here, prism math. You really are. They don't actually tell us enough to solve this question because they don't indicate in any way if this is actually a square or not, right? So they should, by rights, have this sort of situation, right? If there's a shape, now it will always be like this, say on a test or something like that. If there is a shape that you are expected to know that all the sides, it would be like that, right? This symbol means that all 4 of those sides are equal. And we're given 5.2, so we know that our perimeter is going to equal 4 5.2s, or just 5.2 times 4 of those, right? So that's going to be 20.8. We see that is correct. And now for the circle over here, we know we're looking for the distance around the outside, which is the circumference. Circumference of a circle is pi times diameter, or circumference is equal to 2 times pi times radius. We can use either of those. So the circumference here is going to be 2 pi 28, right? Which is going to be 56 pies, which would be delicious. I will take at least two, please, for supper today. I would like one turkey and one apple, please. Turkey or lemon, actually. Yeah, let's go with lemon today. A turkey pie for supper and a lemon meringue for dessert. Seems good to me. 56 pi. Hit enter there. That's going to be about 176. About 176. Good. All right, good stuff. So now let's do the area of a few different figures as well. So where you weren't responsible for doing this sheet, I'm not going to be too scared about showing you all the answers to it. So there it is. So now the area of each figure. Well, for 3A, that's super easy, right? Because 3A above here. For a rectangle, so area of a rectangle, again, is just length times width. So the area of this rectangle is going to be 7 times 2, which is 14. Now for 3C, I'll do this one over here next. The area of a circle, we know, is pi times radius squared. Right? So then what we have here is pi times 4 squared, which is going to be 16 pies, which is going to be exactly 48. 16 pi, 50, 50.3. Yep. Pi is, of course, exactly 3, as the Simpsons have told us. Now I'll just do this triangle there. So let me get you some more paper folding noises onto the microphone. Wonderful. So this triangle here, this is going to be 4B. Area of a triangle. Oh, there we go. My mistake. We were gone right off the page. Area of a triangle is going to be equal to a half the base, which is 12, times the height, which is 7. Half of 12 is 6. 6 times 7, 42. 42 centimeters squared. All right. Good stuff. Good stuff. So that is everything that I meant to get to today. Renetta, there's another peek at the notes there for that guy. Right. That was everything that I wanted to get to today. Wonderful. Now on Fridays, I am going to, after I don't finish my stream, I think I'm going to switch over and play some games, maybe. Today, before I do that, I am going to take a bit of a break and see if I can get this whole bitrate nonsense sorted out. Maybe we can stop dropping these frames. I dropped 2.4% of my frames today. That's really unfortunate. There's not a ton I can do about that. If you want to stick around, you can just hang out in the stream. I'll be live again in a few minutes, probably like 5 or fewer. And we are going to play The Long Dark, which is a super cool sort of, it's not really survival horror game, it's just survival. It's just a survival game where the plot is that there's this, like, it's off the coast of BC, and there's this big geomagnetic catastrophe that BC as in British Columbia. Geomagnetic catastrophe that happens while you're flying your bush plane over an island. Your plane crashes, and then you're basically just in a random spot, and you've got like beaten up clothes on and stuff, and you've got to go out and survive the winter. It's a super cool game. I'm going to play a little bit on the hardest difficulty of survival mode, because I like playing games on hard difficulty because I'm a masochist. Yeah, and it's a little bit, it's a touch on the nose maybe for social distancing, but we will be very socially distant whilst playing TLD. Can you play, Brittany? You can get the game yourself and play. It's a great game to do this week. Actually, this week, any sales of the game, I believe, on Steam are going to, it's on sale, and it's going toward COVID-19 relief. Actually, they're donating their proceeds for this week to the WHO. They have a quite nice message on the start of the game, talking about social distancing and encouraging people to go along with it. So yeah, to my mind, they're being Hinterland. The developers are being very socially responsible, I think, in that. It's a game made in Canada. What do I play it on? I play it on computer. It is available on consoles. I'm not sure if it's on Switch. It is definitely on Xbox and PlayStation. But I'm going to play right here on my old PC, my chubby rig. That's right. But anyway, I'm going to stop the stream for just like I said, just a brief moment. I'm going to refresh my beverage, and then I'll be back before 2:30. I'll be back in like 5 minutes or fewer. Heard that this virus is going to be back to normal soon. Uh, be skeptical about who you hear that kind of stuff from. You can't believe any of that till it happens. Um, Newfoundland here, like we are more isolated than most places. Although I mean, the Toronto to St. John's pipeline is like there's loads of people coming back and forth, right? And Toronto's a major world city. Um, I don't know. I think it's going to get worse before it gets better. But you know, we are all doing everything that we can, right? And that's the best that we can do. We should really be proud of the effort that we're putting in to sort of keep each other safe and to keep our vulnerable population safe. Um, yeah, SARS-CoV-2 is just starting yet. It may indeed be. Testing kits, the testing technology is improving by leaps and bounds every day, which is really good. It's super important to get fast tests with quick results that are cheap. That's really good. And yeah, we're taking some pretty good social measures to try to flatten the curve and to slow the progression of the disease, which is really good. Um, but I would say be skeptical, be very skeptical of anybody who tells you uh, how long it's going to be before this social distancing ends. Be extremely skeptical. And when it does end, it's going to end gradually. It's not going to end all at once. We're going to phase back into normal life, right? But for the time being, all you can do is keep your spirits up, do what you can to keep working and to keep interested. You know, find some projects to work on the weekend. Create something. I don't know, write something, draw something, paint something, build something in your house. You know, plaster and paint. I don't know, whatever you got the supplies to do to keep yourself focused and to keep yourself doing something. I mean, it's exactly what I'm doing, and it's helped me out through this whole week for sure. Um, is it going to come back next flu season? It's not a flu. All right, COVID-19 is not a flu. It has symptoms similar to a pneumonia. In a lot of Asian countries, they're calling it the English translation of what they're calling it is new pneumonia, which makes a lot of sense. The symptoms are very similar to a pneumonia. Um, it is not a flu. It is quite different indeed. Um, but yes, it may stay around and it may make its rounds every year. We don't know. We don't know yet. Um, Maybe that we get a vaccine and we basically eliminate it because it might be that it doesn't mutate fast enough to have different strains. Um, there is the chance of a second wave, Brittany, is I believe what you're talking about. A second wave would be if we if we ended social distancing all at once, and if we just went back to normal life, it would rebound and it would come back because it's not even come back. It's not even gone yet. It's still here, obviously. It's all over the place. I mean, look at all the new cases every day in Newfoundland, right, and in Canada and in the world. I mean, look at the eastern United States and what's going on in New York, especially right now. I mean, the governor in New York is taking great steps to try to slow the progress, but it's there. It's there already, and it is progressing, and it's going to keep progressing. But yes, if we have to be very careful about when we end social distancing and how we do it, how we gradually phase it out, because do I think it's the end of the world? Absolutely not. Absolutely not. This is not at all the end of the world. Not even close. We have seen plenty of diseases, of contagions before. You know the word quarantine? You know the word quarantine comes from the Latin word quaranta. It was from Italy. It was from Italy originally. It was if a ship came, I can't remember the exact details, but if a ship came to Italy from a place where there was a known contagion, or if the contagion was known to be on the ship, they would force them to stay and not dock for 2 weeks. So humans have been dealing with contagions and diseases since basically since our recorded history, right? It's always they've always been around. We've always survived them, and we're going to survive this one too. We've got way better technology than ever before, and we've got the internet right now that we're talking over, right? It's a huge difference in society right now. Because people mostly stay the same, but the technology, around us, that changes. That changes absolutely for sure. Oh, well, the world goes on with or without humans. Yeah, that's true. That's that's absolutely true. The world itself, the natural world, will be quite fine with or without us, but human society will be totally fine after COVID-19 as well. But it's going to take adaptations. So wipe out half the population, not even close. It's not going to wipe out half the population, no. But it is what it is going to do. It is going to take major adjustments on the part of society to take the steps that we have to do. It's going to require a lot of strength of will, and it's going to require a lot of perseverance because these steps that we're taking are not going to be phased out anytime soon. Um, it's going to be quite a few months yet. But again, be skeptical of me telling you a time frame too. What do I know? But we do need to persevere basically, and just to tough it out and just do whatever we can to slow the progression and to be as safe as possible. Actually, there's a lot of domestic violence going on. Well, let's hope not. Let's hope not. I did see a rather depressing article on Reddit that lawyers are expecting divorce rates to spike. But I mean, lawyers will, lawyers will make money off anything, right? There we go. There we go. Instead of worrying about COVID-19, we can all just hate on some lawyers. That's fine. That's fine. They're used to it, is what I'm saying. They're it's part of the job, right? Anyway, yeah, I don't want this to become my COVID-19 talk stream or something like that. But yeah, I mean, the reason I started doing this was because of social distancing and just so that we could have some normal teaching to keep ourselves entertained and to keep ourselves busy. Hope you're enjoying it and benefiting from it. And I'm glad to be here doing it. And yeah, just keep staying safe. Follow public health advisories. Pay attention to the news, but be very skeptical as well of anything that people are saying that sounds too good to be true or too extreme, right? And yeah, try to keep a balanced news diet of good sources, like with you know WHO or the I don't know, the Canadian Health Authority, Newfoundland Health Authority, right? But yeah, please stick around for just a moment. Y'all can keep chatting in chat if you'd like, but I am going to take the stream down for a second, and then we're going to come back in a different category with a different title and hopefully fewer drop frames. Okay, so yep, please stick around, and I'll be back